Hello, everyone. Thank you for joining us. Welcome to part one of a two-part series on root cause analysis. Today's presentation is Digging Deeper Beyond Traditional Root Cause Analysis with ASQ instructor Dani Picciotti. Before we begin, a few housekeeping items. Only the panelists are displayed and heard, but we do want to hear from you. We would love to hear your questions on this topic. Please submit questions at any time during the webinar using the Q&A panel. Please do not use the chat or else we will not see them. So please use the Q&A panel. We've gotten some questions on this pre-webinar. Just confirming that we will be sharing the recording link to the webinar. You will receive the video replay and the slide deck, ideally within 24 hours after the event is our goal. A little bit about us. Your host today is Intellect. My name is Raquel Cloyd. I'm the Business Development Manager here at Intellect. In case you aren't familiar with us, we are an out-of-the-box, no-code compliance, quality management, and environmental health and safety software solution. We work with companies across various industries to help them automate their quality and EHS processes, save time preparing for audits, maintain compliance, and to do so efficiently and in a user-friendly manner. I'd like to introduce our speaker today, Dani Picciotti. She has over 25 years of experience in quality and mission assurance organizations across many industries, including Fortune 500 companies. She is process-focused, emphasizing continuous improvement and value-added activities. She is an ASQ course instructor, and she recently developed a curriculum for ASQ on root cause analysis. We will link to that course at the end of the presentation. Dani is president of QMS Alliance. And at this point, Dani, I'll hand it over to you and you can share more about your company.
Thank you so much, Raquel. As she said, I'm Dani Picciotti, president of QMS Alliance. We are a consulting firm based out of San Diego, California, working with companies of all sizes, whether it's to improve your internal audit process, problem solving, or even supplier management. We have access to consultants across the country, whether it's in medical device, aerospace, automotive, or even pharmaceutical. So if anyone has any questions, we'll be sharing some of my contact information on QMS Alliance at the end of the presentation. Okay, our objectives in our time together is to look at some various problem-solving methods that are out there that many use for root cause analysis. There is no one preferred method. There is many that can serve your different situational or problem needs. We'll just do a little compare and contrast. We'll talk about some tools that you can use based on the frequency of your problems, a one-off versus something that you might see as recurring. We'll look at some specific tools beyond the 5 whys, including a logic tree, to expand the opportunities of identifying potential causes. We'll look at flowcharts as an integral part of the root cause analysis process to identify not only where the problem occurred, but potential causes of that problem in the process flowchart itself as a way to uncover some of those hidden or not so obvious causes of your problem or situation. So let's start off with poll question number 1, just to get a little idea of where folks are in our root cause analysis journey today. You should be seeing a poll popping up on your screen. If you could just select all that apply, what tools are you using now to conduct root cause analysis? Whether it's Post-it notes and whiteboards, do you have a form that your company has for this kind of activity? Do you use spreadsheets? Is it something that's a module in a QMS software or some combination of the above? So we'll give it a few moments for folks to weigh in, and we will be sharing the results just to see what tools are used in this activity for root cause analysis. And we've got a lot of folks online, so interesting. We've got a nice spread of activities. From using Post-it notes and whiteboards, a lot are using company forms. I'm sure there are many industries that require a specific documentation on a formal structure. Spreadsheets, interesting, not too much in a specific QMS software. and a nice healthy combination of the above. So lots of opportunities there to think about how we capture what we do in this root cause analysis. There's so many different resources available to capture all the information and the investigation tools that we use. So let's do a little compare and contrast of some models for root cause analysis that are out there today, some pretty popular ones. So the first one is the A3, and this was developed by the Toyota production system a few decades ago. And A3 is actually a paper size, if you can believe it or not, if folks didn't know that. It's a way to capture the problem, the issues in a one-page format. So not only the team, but even upper management can understand the problem and the progress of the investigation. And you can see the steps there in the A3, from definition of the problem, stating the goal, or what are we trying to achieve in this root cause analysis, getting into the root cause analysis, try to solve our problem. Countermeasures are the corrective actions. Then confirming is the evaluating effectiveness of those countermeasures or actions. And then identifying any future actions to institutionalize or implement those actions into a more permanent process, whether it's updating procedures, policies, forms, etc. Our next process is the 8D or 8 discipline process. And this came out of the automotive industry a few decades ago. And you can see some similar activities in the 8 discipline. What's a little different from the 8D to the A3 is that 8D is very specific in a team-based environment. 8D encourages a multifunction team to participate in the problem-solving process. From describing the problem, identifying containment actions, as in how big this problem could be, then getting into defining and verifying the root cause, choosing and verifying the corrective actions, validating and implementing corrective actions, and then in the prevent recurrence, as in institutionalize those actions not only in the current process, but even similar ones to prevent occurrence in other areas. And then recognizing the team for the accomplishments as they then disband and go back into their regular functions. The next process comes out of the Six Sigma environment, DMAIC, as it's kind of colloquially called, and that stands for define, measure, analyze, improve, control. And in the Six Sigma process, DMAIC can be used for either problem solving or a continuous improvement activity. And there's very similar activities that happen in each one of those steps, like the 8D and A3 processes. And the last process we're going to talk about here is the one that's actually kind of the basis of this presentation today, as well as some publications out of ASQ. This 10-step model was developed by a gentleman by the name of Duke Oakes, who's a longtime ASQ instructor and author. And you'll notice, similar to DMAIC, 8D, and A3, there's some very similar steps defining the problem. What's different is you'll see the more detailed steps, understanding the process, identifying possible causes, collecting, analyzing data, and so on. The way Duke approaches this problem-solving process is to provide some very specific systematic activities. They're very similar to the other ones that are on screen as well, but they provide a little more detail to focus the team on the problem at hand and try to reduce, if you've heard the term, scope creep. So there's an opportunity, and we'll provide some references at the end of this webinar, how you can look at or get more information on this root cause analysis process using the 10-step provided by Duke Oaks. What I really like about this one is it provides a nice sort of sequential approach using our common tools. You've heard 5Y, fishbone diagram, etc. And then also gives you the opportunity to delve into the data that you would want to collect and analyze to address those potential causes that you've identified. So a little food for thought. There's no right or wrong tool to use. They're all very good, and they're slightly different in their approaches, content, and even level of detail. So hope we've given you some things to think about and maybe some topics to explore for your next root cause activity. So moving from our models of root cause analysis, let's talk about understanding the process. This is step 2 in the Duke Oaks model, and it's very similar or embedded into the other models as well, A3, 8D, and the DMAIC. What I really like about the understand the process model, go back, is using a flow chart when you've identified a problem. Creating a flow chart or using one that you may already have in a procedure allows you to identify the ending boundary of the process, as in where the problem was found. Then you can work up into the flow chart to figure out where the problem could have occurred. What steps in the process could have initiated or originated the problem that you've identified today? What's really nice about a flow chart is you can approach this at a high level, not get bogged down into the details just yet, but identify what are the major steps between where the problem could have occurred and where it was found. And then you can break it down into more detail as needed. So let's take a look and see what that means. So in this flowchart example, we have what's called a level 1 flow. And you can see we've got 5 big process steps in reserving a hotel room. There is the get requirements. You know, if you think about when you last went online to book a hotel room, you had to identify what were the requirements, the dates, the location, maybe even the type of hotel. Then that information gets entered into the computer in some way, shape, or form. Each hotel website has many different things that you need to click and check and confirm. Then that computer, in some way, shape, or form, schedules your stay and sends you a confirmation email. Then hopefully the room is reserved. What's really nice about this big process step flow chart is it not only defines the steps that are involved in the process in sequence, it can help you identify where the problem could occur, which could be in more than just one step. Along with identifying where it could occur, a flowchart actually helps you identify the possible causes of your problem in each one of those potential process steps. Along with that, each process step has an opportunity to collect data. Or even more specifically, you can identify in each process step where you are already collecting data that can be relevant to the problem you are trying to solve, the root cause you are trying to identify. So thinking about those big process steps to identify where the problem can occur can lead to what could be the causes for the activities in that step, as well as what data is available at that process step that you can then collect and analyze related to your problem. Now, that top level process flow gets us to the start of what our problem is and where it can lead us to that root cause analysis. Well, if you think of a process as, I'll use the term SIPOC here, for every process, there is an input from some type of supplier. And that supplier could be an internal supplier. It could be the inventory function that sends you a kit. It could come from an external supplier that is providing you product or components into your own assembly. Then the process that you perform, whether it's production, processing, or servicing, produces some output to a customer. And that customer can also be an internal or external customer. You could move from one production step or process to the next, or move from your internal process in shipping to a customer. So using the SIPOC model, if you will, thinking about our level 1 high process flow in reserving our hotel room, we can look at each process step and understand where our problem, maybe our room didn't get reserved, could have occurred. With that question in mind, we can look at each process step and possibly break it down into a more detailed level 2 process flow. So think about that. Each of your major process steps can then be broken down into a more detailed process flow to understand where in that major activity could your issue or problem have occurred. Could the entry into the computer have occurred? There have been a problem with the date, the number of rooms that was entered, or even the price code or coupon code. Understanding the process gives you insight into where the problem occurred and even down into the activity or activities that could have generated the problem that you're dealing with today. What's nice about this concept of the flowcharts and why flowcharts are really so important is that every problem occurs in some type of process. And each process is part of a larger system. So if we think of our SIPOC model, each SIPOC, supplier, input, process, output, customer, is really just an input into another process, whether it's an internal process or something that you're sending external to a customer. These process gaps, if you will, the error that you're dealing with, can be, or what may be highlighted, is that there's a lack of a defined process. The process in and of itself doesn't have the level of detail that could be followed consistently. And that lack of defined detail can then cause the problem that you're dealing with. The process may be defective in that it may not consider all the different variations that the process may have. It may not be consistent. And that inconsistency can lead to the problem or issue that you're dealing with today. Process not followed is something that can certainly occur. If the process is defective, doesn't cover all the possibilities, then the process could not be followed. It's not that the human in the process decided not to follow the process or the instructions. It just may be that they could not follow them because it was not descriptive or did not cover the situation or the activity that they are actually working. The intent and really the foundation of using flowcharts is to keep the focus on activities, not the people in the activities. When you look at the activities, you get an understanding of not only the inputs and how consistent they are or are not in your activities or in your process, and that can then lead to the consistency or inconsistency of the output. We don't want to play the blame game. We don't want to blame the human. We don't want to always say operator error, because there's many things that are happening in each of your activities in your flowchart that could lead the human to error. And if you look at the note down below, and I appreciate this note, that all errors in human systems to a point are actually human errors because a human designed the system. And at the time, there was only so much information, equipment, budget, or human resources available in designing that system. So we have the opportunity to recognize humans are a part of any process, but it's not the human that is the cause of our errors. There are many things that are happening around the human that can lead them to error. And I do hope I get some good questions on the use of flowcharts, because it is such an amazing visual tool to help not only the team that's working this root cause analysis, but all those that are in the process or managing the process to understand where errors can occur and what other opportunities for improvements might be available just in understanding the process flow. So from our process flows, let's look at some tools that we can use to identify those possible causes. But before we do that, we have another poll. Thinking about what you use today, what is your current go-to method used in root cause analysis? Do you tend to use more than one tool over another, like the 5 whys, a fishbone diagram, a fault tree analysis, an FMEA, or a design of experiments? What tool do you use most often in your root cause analysis? So we'll give it a few moments for folks to weigh in. See, where are the popular tools? Interesting spread, and not surprising. The 5 why tools is the most popular. Behind it is the fishbone diagram, then failure modes and effects analysis, design of experiments or DOE, and a fault tree analysis, kind of bringing up the rear on that one. And I'll say not surprising, because the 5 whys is a great tool to get to the systems, the processes that could be causing your error to occur. Oh, there we go. So some of the tools we're going to talk about today is using the flow chart. The steps in the flow chart is a great way to identify potential causes. We'll look at something called a logic tree, which I'll call a supercharged 5 whys, a way to expand your view and even line of questioning. And then as a bonus prize, we'll look at a tool called a barrier analysis or controls analysis. Recognizing there's so many other tools, even like the fishbone diagram, that are out there, but these are a couple of tools that we're going to be highlighting today. So the flow chart, we mentioned the flow chart in itself gives you a visual of what activities are happening, and based on the problem that you've identified, you can go into each step in the flow chart and ask the question, could my problem have originated here? So for example, we have errors in auto repair invoices have increased from nearly 0 to 3% in the past 2 months. So our problem is really with errors in auto repair invoices. And here is our high level process flow on getting the repair invoices. And we can ask at each step in the process, could the errors on the invoice have occurred here? And work our way up and to see if there could be more than one process where that error could have occurred. And then based on that identification of one or more process steps, you can then create that lower level, level 2 process flow and delve deeper. And the intent here is to rule in or rule out different steps in the process. Which steps could have led to that error? Which steps could not? That helps you focus in on the potential causes, as well as even what data you could collect to verify or exclude some of those potential causes. The 5 Why analysis, a popular tool, as we saw in our poll, a great way to approach a problem and understanding the whys of it. There is some interesting or potential limitations of a 5 Why in that it can be considered kind of a linear view of a problem. And what I mean by that in our example here, let me do the little setup. In this particular example, the homeowner just put on a new roof. And oh, by the way, they have a gravel driveway. So in the last week, they had 2 flat tires. And you would ask, well, why did I get 2 flat tires? Because I had roofing nails in my tires. Why did you have roofing nails in your tires? Well, because I ran over the nails in the yard. Well, why were the nails in the yard? Well, the roofers didn't adequately clean up after they finished installing the roof. Well, why didn't they adequately clean up? Cleaning up meaning the nails. Well, the magnets that they were using to clean up didn't work well in tall, thick grass. Perfectly makes sense that a magnet that didn't work well in tall and thick grass led to nails being in the yard, that when the homeowner drove through that, they got roofing nails in and got 2 flat tires. The big elephant in the room question might be is why was the homeowner driving in the yard that led them to run over the roofing nails? You might not get to that kind of question in a linear 5 Whys. Not to say that you won't be addressing part of the problem, but there could be some bigger elements that you may not be covering or even in your field of view capturing in doing just one 5 Why. So let's help you out with this one. A way to expand your field of view is to use a logic tree. Essentially, it is an expanded 5 Why. In this particular example, our problem was a calibration error. In a logic tree format, you can identify all the potential elements that could contribute to a calibration error. In this case, equipment, standard, information, technician, and environment are all elements that can contribute to a calibration error. And then you can ask why or how could any one of those elements cause our calibration error? Was there anything wrong with the equipment we use, the standard we use, information, technician, etc.? In this particular problem, we found that there was an issue with the standard that we were using in our calibration process, which led to our calibration error. Then we can ask why or how would a calibration, why or a standard lead to a calibration error? Maybe it was the wrong standard, the standard wasn't stabilized, or the standard itself was out of calibration. And then you can, ask the whys and the hows. And you see that I've added the word how here. And I've done that specifically because the term why can be a difficult word for some folks, in that why can put you on the defensive, thinking that it was a personal choice that we caused the error. If you use the word how, as in how could a standard cause a calibration error, now you're focusing on the activity and not necessarily the person or the person's choice. So the calibration error here caused by a standard that wasn't stabilized, you get the opportunity to explore other potential causes instead of just one particular linear in just a single 5Y. So I'm sure I'll get some good questions on this. Great way to expand your view in a 5Y type format, considering more than just one potential cause. Another example that we have is, in this particular case, an audit nonconformity was that 2 employees had not received their required SPC training. Using a logic tree, we can say, what could or how could our employees not receive their SPC training? Was it that the class wasn't held, those employees were not scheduled, or they were scheduled but missed the class? And then the why or how, in this case, was the class not scheduled? Well, there was not enough to hold the class. We didn't have a minimum number of attendees, so we couldn't hold the class. So you can see this can be both in a manufacturing or even administrative process type of view. I'll even throw out that I have many friends and colleagues that have chosen in the 5Y tool usage, not necessarily for the logic tree, but they'll do a 5Y on people, 5Y on process, and a 5Y on product. So it's a different kind of approach. You may look at each one, people, process, and product, as its own sort of linear 5Y, but because you're doing 3 5Ys, you're still expanding your view. So an opportunity to use the 5Ys in an expanded method or expanded viewpoint, so you can capture potential causes that may not be so obvious in only doing one 5Y. So think about our logic tree from our calibration error. There are many different ways you can construct your logic tree. Thinking about what functions that are involved in that particular process or in that particular service. It could be sales, inventory, purchasing, production, quality, shipping. The failure modes, identified failure modes. How could the process fail? And how would that relate to the problem that we're dealing with? The features or the attributes of a particular product, process, or service, whether it's a functionality, size, appearance, other critical characteristics, whether it's dimensional or operational. System modules or the bill of materials. You can break it down by assemblies or sub-assemblies down to even individual components that could contribute to the failure that you are addressing. The process, using your flow chart, the steps in the flow chart as a way to build your logic tree. Which steps in the process could have contributed to that failure or failure mode? And then the last one there is the 7 M's, thinking the sources of variation: manpower, method, material, machine, Mother Nature, management. And management not being people, but management of processes and resources and things like that. So the use of a logic tree can be quite beneficial, or at least an expanded 5Y tool, very beneficial in your root cause analysis. to give you that breadth of options or potential cause sources. The next tool we have here is called a barrier analysis. And it's the opportunity, or it's called controls analysis. It's an opportunity to look at your process, and I'll use the production kind of process as the example. What controls are in place that should have prevented the problem, and did they fail? There could be things in your production process. It's a fit check using a particular fixture or a testing stand. Those could be the controls that are in place that should have prevented the problem. Did they fail in some way, shape, or form? The next question in barrier analysis to say is, what controls are in place that should have detected the problem, and did they fail? Thinking inspection, test, whether it's done by quality in the traditional inspection and testing function, or are there inspection and test elements throughout your production process that may not have performed as expected and was unable to detect that particular problem? And then there could always be the combination of controls that should have prevented and controls that should have detected, and did they fail? Those barriers, those controls, are useful sources of data to verify, as in rule in or rule out, a potential cause. So those things that should have prevented or detected are great sources of data to verify any particular cause that you may have identified. So here's an example combining the flow chart and the identification of potential barriers to identify some potential causes. So we're using our incorrect auto repair invoices as our example. And at each step in the flow chart, we can ask, what, if any, controls were available to prevent or detect a potential failure? Did they fail? And you'll see the categories that we have are people, equipment, material, and information, or even data. And we've just put in a few for examples, but this is a great visual tool to not only develop what you believe are the barriers to prevent and detect, whether it's people, equipment, material, or information, but as a way to solicit input for those that are involved in the process directly, to get some additional insight into what could have happened to cause the failure or the problem that we're dealing with today. Also, this is a great way to capture the information, not only for the current investigation, but also to use in potentially future investigations as well. You've now got some good historical data based on the process and the information at the time to identify the potential causes and the data that you can go collect to rule in or rule out any particular cause. So very nice visual tool. You can almost tie this in with a logic tree or 5 why as well. You can use several tools together in your root cause investigation. You don't only have to use a 5 why or a fishbone diagram. In fact, using several tools in the process can hone in on some of your most likely causes, and even giving you a greater field of view on the process to see if there's anything else you may have missed by just using one particular tool. So we think about the sources of cause information. Where would we go get data? Where would we go get some input to verify, rule in or rule out a potential cause? First and foremost, those are involved with the process. Either someone who designed the process, designed the workstation, the production line, even the process in and of itself, the work instructions. Those who operate the process, those technicians, operators, machinists, even inspectors. Those who maintain the process, those that do the preventive maintenance or the maintenance of your equipment are great sources of potential cause information. They may have insight into how things have been running most recently, and if anything is different than in the past. Suppliers and customers are also great sources of potential cause information. What are they seeing for what they're delivering to you from a supplier or what they're receiving from you as a customer, both internal and external to your organization? Technical staff, engineers, other scientific personnel, process engineers, material engineers, chemists can provide some great information on the probability or the likelihood of any potential cause. And then lastly here, some expert systems or other diagnostic guides. Many companies use an FMEA to not only design a product, but also to design a process. HazOps is hazardous operations, whether it's chemical hazards or just the activity itself, hazardous to the human, for example. A HACCP analysis, hazard analysis critical control point, that comes out of the medical device pharmaceutical industries. And then also equipment manuals is a great source of information. They've got troubleshooting guides in most equipment manuals. So those are some good information to use in conjunction with your tools, whether it's a logic tree, a flow chart, and or a barrier analysis to hone in on the most likely causes of your problem. In that there are so many causes, potential causes of any problem, it's really your opportunity in the root cause analysis to focus in on the most likely. Try to hone in on, because you don't have unlimited time and unlimited resources. Using the drill down processes like the flow chart or the logic tree reduces the number of potential causes that you're going to investigate further, and provides you some great specific data sources to confirm or exclude a potential cause that you've identified. So the tools, the reason why we use the tools in and of itself is to help us narrow down the potential cause field. And we've got one more poll question here before we do a little bit of a wrap up. So in today's environment, what are your biggest problems right now with your root cause analysis? Does it feel like things are rushed? Does the team need more training? Does it feel like it's more of a reaction than a proactive activity? Do you wish the process could be a little more automated? Or do you think it's a little too narrow and you might need to find a bigger picture? Get a bigger field of view in your root cause analysis. So we'll take a few moments and let folks weigh in on that. And we'll be sharing the results shortly to see where folks are feeling today on their root cause analysis issues. Oh, interesting. So a little kind of in the feeling pressured, a little rushed. Training is certainly something that many organizations are dealing with, as especially new folks are coming into their organization and into the process, and feeling like it's always a little reactive, and they're not using the RCA process to be more proactive. Interesting. Very cool. Well, thank you so much for this. Kind of just a feeling like where things are. Hopefully, the topics that we've just done at a high level today have given you some some insight, maybe some opportunities to go pursue some additional information, even training.
All right, thank you so much, Dani. That was extremely informative, and I know I learned a lot. I hope you all did as well. We are going to have a Q&A session. Before we get into that, as I mentioned before, this is a two-part series. Dani is going to return on July 12th, and she's going to speak on getting started your RCA process on the right foot. We will send out a link to register for this event when we send out the video replay and the slide deck. As promised, we'll also send out the link to Dani's course. And finally, I do want to invite you all to a demo that we are going to host on July 19th, where we will share how you can manage CAPAs, RCAs, and nonconformances using Intellect's QMS software. All right. So now is the time for our Q&A portion of the event. If you haven't yet gotten a chance to ask your question, please put it into the Q&A panel. We're going to go through and get some of these questions answered. Let's see here. All right. Let's see, we have one question here. Has there been noticeable study or analysis of errors caused by AI-generated processes?
Oh, great question there. I personally have not seen any, but I do know that there are some studies out there at present, and I will actually try to see if there's anything out there published within ASQ or other similar type organizations, but I haven't found any. I think because it's still an evolving kind of not only process but issue. So certainly something that will be emerging in both studies and trend analysis for sure. But I haven't seen anything yet.
Okay. What about prevention methods? That is another question.
Oh, prevention methods. Any more on that question?
That was all.
Okay.
The question.
So prevention methods. So great question. There are some, as you move through the root cause analysis process and start selecting your solutions, you can be looking at which solutions would be a permanent, as in would eliminate the cause from happening again. The FMEA process, a failure modes and effects analysis, if your organization does that, can identify some methods to either eliminate causes or reduce the likelihood of them occurring. For those that are in a production environment, lean manufacturing tools, and I'll use the nice one called mistake proofing or poka-yoke, are great ways to look at prevention, trying to reduce or even eliminate the likelihood of human errors. Preventions usually come as part of the corrective action and looking to prevent the not only recurrence but occurrence in other areas. And to complement that is to actually check in with your technical functions, engineering or even manufacturing engineering, to see what, if anything, they've identified in an FMEA for a design or PFMEA in a process failure modes and effects analysis.
Okay. Could you discuss how the nature of the problem may impact the choice of the tool used?
Ooh, good question. Yes. The nature of the problem, and I'll interpret that of, is this a recurring problem or does this seem to be a one-off? Like it hasn't happened before, it's a random occurrence. So there are some tools that are better suited for more of the recurring problem, maybe like the fishbone, possibly even the 5Y. Those that seem to be more of a one-off, there are some, not that you can't use a logic tree or a fishbone diagram even for a one-off, but there are some other tools. There's one called a G chart, if you will, sometimes even a failure analysis depending on the type of failure, might be a good way to start with the potential cause if it's not something you've seen over the course of time. So there are some tools, and there's some nice ASQ, American Society for Quality references, that you can find to give you some more ideas on those recurring versus random occurrence type failures.
Okay. This questioner said, we use 5 whys for RCA. How do you guide people to not make the whys lead to the corrective measure they already have decided is the fix?
Yes, I can so appreciate that. So often in a root cause analysis, even starting at the problem statement, there is the tendency to try to presume a corrective action. And take someone who understands not only the process of a 5 why to guide the data-based decision and trying to, capture any of their supposed corrective actions off to the side and keep them focused on the process and the activities in the process that could have led to the failure. Not a bad idea to gather some thoughts on corrective action off to the side, but really trying to separate corrective actions from the process steps that could have generated the problem. That's why I like to use the how versus the why word. How could this have happened drives you to the activities. The why can kind of open things up for choices or other, non-procedural type activities, if that makes any sense. I hope it does. But yeah, trying to focus on the activity and capture any of their potential corrective actions off to the side that you can use later would be a good way to kind of separate those biases, if you will.
Okay, thank you. Another questioner says that many times they're performing RCAs with very busy people. How do you get buy-in from them to go from a simple tool like the 5 whys to something more complex like the logic tree?
Appreciating that everyone's busy. So you could look at this as kind of a progressive activity. Maybe you don't need to get everyone in the room all at the same time for several hours. Maybe it is trying to do things in 30-minute activity chunks. Or use a collaboration type document, whether you're using SharePoint or Teams or a Google Drive, and ask folks over the course of 2 or 3 days to put their inputs on that, and then we'll do a summary review maybe at the end of the week or for a 30-minute review, trying to keep things in kind of bite-sized meetings, and it doesn't feel that they're going to get half a day sucked up. It also allows you to get more people involved in the process that may not be able to attend any one particular meeting. You can certainly capture their inputs in those collaboration documents and then review it by that core RCA team.
All right, thank you. And we have a lot of questions here. We're going to keep going just to let everyone know we've got 5 minutes left officially, but we're going to keep going beyond that. So we will try to answer as many questions as we can, and anything we don't answer, Dani has offered to answer offline. Before we go on to the next question, I did want to let everyone know that we've got 2 QR codes up on the screen. If you hold up your mobile phone, turn the camera on to the QR code, you can connect with Dani on LinkedIn. That'll take you immediately to her page. Or if you'd like more information on our Intellect QMS and EHS software, you can hold your phone to the QR code on the other side of the screen to schedule a demo. So let's continue on with the questions since we do have a lot here. How do you determine when an analysis needs to be done versus when it might be overkill?
Oh, great question. I would probably start with looking at the severity of the issue or problem. In some cases, if it is a minor issue, did not cause a great disruption, you may be able to look at solving, I'll call it the immediate cause or contributing factor. If it's a broken tool, then maybe go fix the tool. If it's been a more serious issue, caused maybe a production line down, or has come from a customer complaint, those are the kinds of things that you would anticipate would require more of an analysis. In addition, if it's a random occurrence, then maybe you don't need to do a lot of analysis now, just recognize that it did happen and monitor for potential trends. If this is something that you've seen recurring, whether it's in the same week, month, quarter, or year, if it is a recurring issue, that can certainly be an indication that an analysis would be encouraged. So you're not just addressing a symptom, that you can actually get to the infrastructure, process, procedure that may be allowing that issue to continue and repeat.
Okay, thank you. Next question. When you start, do you keep the process flow high level and let participants fill in the details? Or do you create a very detailed process map to drive the discussion?
I recommend starting high level first to identify where in the process your problem or issue is most likely to have occurred. And it could be more than one step. Then once you get that high level process flow and kind of agree where it could occur, which step or steps, then you can go down and break it into lower level activities to focus on which activities could have created that problem in that major step. If you get too detailed at the start, that can be distracting, and people will kind of hone in on what they think is the most likely sub activity versus having the group consensus, if you will, on where in the process in general this problem could have occurred. It's nice to start at the big level to get that kind of consensus, everyone's on the same page, and then start breaking it down to achieve that next level discussion and then consensus before you move on.
Okay. Next question. What are the go-to standards if retraining is required?
Ooh, good question. When you talk about retraining, it really, retraining involves or should involve that something in the process or the procedures or even the work environment has changed. That's why you need to train, or, if you will, retrain on those changes. Retraining in general has a very low effectiveness, as in it's just kind of a reminder, this is what y'all are supposed to do, versus what in the process did not work well, and have we actually changed the process to reduce the likelihood of that cause recurring. Retraining itself, just reminding folks what they're supposed to do, not a good solution, and it usually has very low effectiveness. If you want a good, solid, corrective action that comes out of your root cause analysis, that usually involves some type of change in documentation or even work environment. Then the training is on the new or updated process or the new or updated work environment, and that's where you get the biggest effectiveness, long-term effectiveness in your corrective action.
Okay. Could we interchange the term flowchart with value stream map?
Ooh, good question. They're technically not interchangeable. The value stream map has some of the standard flowchart elements in it, but it also includes so much more great information, such as cycle time for each activity in the process, as well as queue time. How long does each product or part may sit before it's actually processed? It includes information on changeover time, and also looks at, I want to say, yield as parts move through the process. So one could say that there's a flow chart embedded in the value stream, but the value stream map is not necessarily embedded in the flow chart because there's so much more. And I encourage you to go to asq.org and click on Learn About Quality. There are links to both the value stream map and flow chart that you can see both the similarities and the differences.
Okay. Do you feel that every root cause requires a kappa? And how do you avoid a kappa happy culture where kappas start bloating and complicating your processes?
Great question. Every problem that you identify, you actually get to determine, and depending on your industry and your procedure, how much, if any, corrective action do you want to do? Medical device, pharmaceutical, even aerospace have some very stringent rules regarding corrective actions. So depending on your product and process, you may have regulatory requirements regarding kappa. That said, there are some ways, and I'm referencing the Duke Oak books, a root cause analysis available on ASQ, where you can work to solve or correct, the immediate, what looks like the immediate cause, broken tool that caused damage on a part. And if you see things recurring, as in you now have a performance trend, then you can identify when you want to go to deeper corrective action. Similarly, how you might look at corrective action with suppliers. Do you issue a corrective action for every single nonconformance, or do you look for a trend of nonconformances and then issue that corrective action for more systemic action going on? Kappa happy, I can absolutely appreciate that because it's kind of part of our culture. If we see a problem, we need to take corrective action. But maybe it's sort of categorizing, are we looking for solving our random occurrences and then monitoring for trending? And then if we see a trend, look for more systemic. I say that assuming that all, nonconformances are created equal, but certainly when you have significantly impacting nonconformances, line down, product recalls, things like that, those are ones you absolutely want to take a more deeper dive. But you can certainly try to temper the kappa happy culture with, when do we need to initiate what level of corrective action, and a little bit of why. And just level setting that environment could help folks be a little more even keeled, as they say, with respect to deciding when kappas are actually needed. They've got some criteria or guideline to help guide the activities of the process.
Great. That kind of answers this related question of, how do you handle one-off issues? I think that kind of answered that question as well. Let's see here. This questioner is thanking you for a very comprehensive RCA process. However, their customers expect all of this to be done ASAP, especially in their industry, which is automotive. Any comments on how to handle such customers?
That's a great question, because of course, the desire to have things solved, ASAP. The key to understanding the process is to really be as transparent as you can. What is the severity of the problem, and trying to at least assemble a corrective action approach to then share with your customer can help them understand whether it's going to take days or weeks to work through the root cause part of it, to then identify corrective actions and then implementation, especially if they have to approve anything along the way. Do they need to approve process changes or equipment changes, as some customers and some industries do? The more transparent you can be about your approach and the timing of the approach with your customers, that can help them understand, what it is that you need to do and why it needs to take so long, and potentially what participation you may need from them. Because customers forget that they too have a role to play in the root cause corrective action process. I hope that helped.
All right, thank you. We've got time for a few more questions, and then we're going to wrap up. So would it make sense then, this is the question, to ask how for each 5 whys to better get to the root cause?
Me personally, I prefer the how, because it drives your thought in the activity, the instructions, and the process, versus the why, which could kind of lead someone to, there was a personal choice that someone made. right? And that sometimes is a hard thing for people to not feel defensive. I like the how personally. You could ask both or ask just the how. I think that could work just fine.
Okay. Another questioner, these tools are great, but has there been a study on how time consuming each of these tools are?
Oh, I wish I could say yes, but because each problem is different, the time it takes to do each tool it varies based on that. Also, it's based on how comfortable folks are with the tool, because sometimes you may have new members on the team and need to orientate them into the process. So there hasn't been any study as to how long each tool takes. You can kind of see just based on the tools themselves, some of them are a little more complex. A fishbone diagram, for example, could be a little more complex than a logic tree. But they both still take a certain amount of time based on the problem that you're dealing with.
Got it. And then final question, like I said before, Dani has offered to answer other questions offline. And you can also reach her via LinkedIn and via the email address and website that we are providing here, and we'll send out later. For internal audit findings, what would be the best approach for RCA?
Oh, good question. I hate to say it depends, but it depends. So based on the internal audit finding, is it an administrative process or is it a production related process? If it's a production related process that could impact product, I would definitely suggest using something like the logic tree or a fishbone diagram. For more of an administrative process, you can start with the flow chart and then see if a logic tree might be advantageous. Actually, the flow chart in the production process is also just as key. And then from flow chart to logic tree or fishbone diagram. Gosh, it almost depends on the type of problem or type of finding that you found in the internal audit process. Is it a one-off or has it recurred? You know, is this a repeat finding, if you will? Could also have you lean more towards like the logic tree or the fishbone diagram to try to identify some more causes. It's hard because it depends.
Thank you. All right, well, that's about all the time we have today. I thank everyone for attending. Thank you so much, Dani, for sharing your knowledge with us. We look forward to seeing you at our next webinar with Dani on July 12th. Thank you so much, everyone.
Thank you.